Hello everyone, very good evening and warm welcome for today's class. I hope I'm audible and also visible. Great, great, great. Thanks for the confirmation. Okay, so I have a doubt which is coming up from Sheetal. So I'll just take this up and maybe we can go through this once again, right? Can we please discuss homework questions? Okay. How many of you have doubts with the homework problems? Okay. There were few things introduced by TS which we did not hear before. Uh, all right. So let me do one thing. TC time. So I will. I've not gone through the assignment yet. So I will go through it once, and I will sure plan a doubt session, maybe 1 hour in the coming class on it. Okay. So right now I've not gone through all the questions in your assignment, and let me go through them after today's class, and maybe in the next class we will do spend some time on these doubts. Okay, so don't worry, if something is we'll keep it on Saturday. Uh, so actually I'm having classes on Monday to Saturday daily. One batch is on MWF and another is on TTS. So maybe Sunday I can do, right? So Sunday I'm available. Sunday is doable, or we can do in the next class itself. Okay. So I will let you know, but don't worry. I will clear all your doubts. Possible in the next class. Okay. So today is what, Wednesday, and I will do these doubts on Friday. Okay. So Friday for sure. We will first start with the doubts, and then we'll continue with the topic. Is that okay? So Friday I will take all your TC doubts plus prefix arrays, whatever it is, prefix sums. So right now I'm don't have the link and I don't see the questions, right. Can we include problems from the beginner test? Okay, I will try to include those. Okay, so I checked with the team, so they said the video explanations were provided, but since you are saying, so maybe I'll look into it. Yes, so I suggest you to go through the video explanations for the contest problems, not for all. Okay. So if there are some questions for which video explanation is not there, I will discuss those. Okay. You don't have those questions. So anyone who has gone through the questions once again, can you tell where those questions are present? Contest questions. Is there any practice section on the dashboard? Sonam says look for the coding contest in academy classes. Okay. So it should be there. It should be there. Okay. So we will take your time complexity doubts in the Friday's class, because I've not gone through the assignments yet. So if I go through them now, it will waste a lot of time. Okay, so we'll do it. Okay, so let me start with today's topics. So let's do a quick recap of what arrays are. So who remembers what is an array? Who remembers what is an array? So array is a container that can store a list of elements. Okay, store a list of elements of the same type. So when I'm seeing elements, I mean objects. So it could be array of dogs, it could be array of strings, it could be array of integers. Okay, of same type. Okay, so container is also known as a data structure. So array is the simplest possible data structure that you will use, right? Right. So if you remember, we did something. We said, okay, if I want to create an array in Java, I will do something like this. I will define int square brackets followed by array name followed by new int followed by the size. Now this could be a fixed size like 5 600, or it could be a variable like some user input n. So user is giving some value of n, and you can allocate array of that size. So we also discussed that. Uh, did we talk about memory management of arrays? What happens to arrays at memory level? Heap memory and the stack memory. Okay, we have talked about it. So this is actually allocated on what part? Stack or heap? It is on the heap memory. It's an object and it gets created on the heap memory during runtime. Okay, that means when the program is running, you can allocate memory during the execution of the program. So this part lies on the heap, and you have something ARR. So ARR lies on the stack. Okay, and we also discussed that once an array is created, it cannot grow bigger. It you cannot change the size of the array. Okay, so the only thing you can do is you have to allocate a new array if you want to increase size, if you want to increase the size of the array. That's what you need to do, right? And we also discussed some basic operations on arrays. So we discussed how you can create an array, how you can insert an element in an array, how you can remove an element from an array, how you can search inside an array. Okay, and maybe how you can delete the array, delete the entire array. So I'm not able to recall because I'm teaching so many batches. Did we discuss the logic for insertion and removal from the array. How do we insert inside in the middle of the array? Or the logic to remove some element from the array. Oh, people are saying yes and no. Even delete was not there. Some people are saying we did, some people are saying we did. Okay, let me quickly recap, right? So let's say I have an array in which I have some data like 1, 2, 3, 4, 5, and I do have some empty space, right? So let's say I want to insert an element which is a number 10, and I want to insert it at the second index. So what we discussed, that we will iterate over these elements and we will shift everyone to the right by one step. So now what happens? 5 gets shifted, it comes here. 4 gets shifted, it comes here. 3 gets shifted, it comes here. And 1 and 2, they stay there. And eventually you get a empty box here, and you can insert the element 10 here. You can say, okay, this element is 10. So let me know, did we discuss this logic? Okay. The same thing is true for removing an element. If I want to remove something, I will have to shift left. Okay, let's say I want to remove the element 3. So what will do? We'll copy these elements to the left. So it will become 1, 2, 4, 5, and maybe this element is now 0. So we can remove an element from an array. Okay. We also talked about searching, right? So we talked about linear search, I guess. Do you remember? We talked about linear search. So in order to search an element in an array, what do we need to do? We need to traverse through every element, and we have to look where that element is present. Yes or no? This is what we did. Suppose I want to search for 4. So I will go through every element and I will match, okay, where is this element present? So we talked about linear search as well. Great. Did we discuss binary search? I'm not able to recall. Inside the only concept, not fully. Not in the intermediate batch, in the beginner batch. Did we discuss binary search? No. Okay, we have not discussed, right? Okay, so what we'll do, we'll start with uh, some basics. We'll start with some basic operations like binary search. Okay, we'll start with binary search. Okay. So what we will do, we'll given an array, right? Given a sorted array, it is only applicable for sorted arrays. So what do you mean by sorted array? An array in which all the elements, either they are in the increasing order or they're in the decreasing order. Okay, so first tell me how you will check if a given array is sorted. So I have a question for you. You have to give me the code. I am going to give you an array. Let's say you have an array like this, which contains, let's say, 1, 5, 7, 12, 15, 20, 28. Is this a array a sorted array? That means the array should be either uh, kind of increasing, means it should be non-decreasing, or it should be non-increasing, maybe something like this. If the array is non-decreasing or it is non-increasing, then we will call it as a sorted array. We'll call that array as a sorted array. So first question is check if the array is a sorted array. If the current element is greater than the previous element, then it's not sorted. Yes. So what we need to do? We need to go and compare every pair of elements, right? So we have to say that okay, I have 1 and 5, 7, 12, 15, 20, 28. So what I need to do? I need to compare, is 1 less than 5? Is A0 less than or equal to array of 1? Is array of 1 less than equal to array of 2? Is array of 2 less than equal to array of 3? Okay. So I have to do this till the last element. So that is array of n minus 1. Okay. Now I cannot write this directly in the form of code. So what we have to write? I cannot directly write this. How should I compare all the elements? Again, we need a loop, right? So we will need a loop. So we'll say for uh, I am starting at index 0. Till what index should I go? Come on. Will it be n minus 1 or will it be n minus 2? So I'm comparing this with this, this with this, this with this, finally this with this. Okay, so I actually need to go till the second last element and I will compare it with the next element. So I can say I should be less than equal to n minus 2, where n is the length of the array, right? So what comparisons I have to do? I have to say if the current element, that is array of I, if this is at any point, if this becomes greater than the next element, suppose the current element is 18, the next element is 16, then what happens? AI and AI plus 1. Is it sorted or is it unsorted? It's not sorted. So maybe you can say that okay, I'm creating a function, so I'm going to return false from that function. We are not sorting the array, we are just checking whether the array is sorted or not. Otherwise, we will say okay, let me return true. That means the array is actually a sorted array. So this I'm doing outside the loop. That means there was no such comparison that returned false. That means for all elements, AI was less than equal to, Kintan says plus 1 will give index bound exception. It will not give because you're only running your I till this point. The last comparison is happening between 20 and 28. You're not comparing 28 with the next element. Okay? The last index is n minus 1. The second last index is n minus 2. So we are running till the second last element, right? Got it? So the last comparison is happening between array of n minus 2 and array of n minus 1. We are checking is this number greater than array of n minus 1? Then of course we will return false. Shashank says, can you explain the if condition again? Of course, Shashank. So what we are saying that let us assume that we are talking about an array which is in non-decreasing order. That means the elements are either same or they increase. Okay. So now what I'm saying that let's talk about this array. So I'm comparing AI. In the beginning, I is 0. So I'm comparing A0 with A1. So I'm checking is 1 greater than 5. If this is true, then the array is not sorted. But right now it's false. Then I'm checking is 5 greater than 7. Again, it's not true. Then I'm checking is 7 greater than 12. Is 12 greater than 15? Is 15 greater than 20? Is 20 greater than 28? That's it. So now none of these conditions is true. So eventually what I say return true. Okay, but if one of these conditions is false, for example, if this is 15, so I say, okay, 15 is greater than 7, that it means the array is not sorted. Shashank says, got it. Great. Okay, so this is how you can check whether the given array is sorted or not. So Divakar says less than n minus 1 will be same as, yes, Divakar. So you can write this as I less than n minus 1. Okay. So Prashant says if AI is less than AI plus 1, return true. Will it be correct? So if AI is less than AI plus 1, if I reverse the comparison, will it be true? Of course not. So we have to check for the entire array. Now suppose you have this array 1, 5, 7, 8, 10, and maybe you have 6, 15. So what you're doing, you're checking that, okay, I will put a loop. If 1 is less than 5, return true. That means I'm just checking that is the first number less than the second number. If that happens, I will return true. So return true means my function has ended and I did not check for the remaining elements. So these elements will never get checked. So we will have to run two loops to know if the array is sorted increasing or decreasing order. So Roshan, what you can do is that okay, I will tell you a trick to do it. Now suppose we have a question from Roshan that we want to check whether it is increasing or whether it is decreasing. Okay. So what you can do is, let's say I give you an array, let's say 10, 8, 7, 5, 2, 1. So I don't know it's sorted increasing or it is sorted decreasing. So let us assume that it is sorted in increasing order. So I create a boolean increasing and I set it to be true. Okay. Then what I do, I just compare the first two elements. I compare the first two elements, 10 and 8. So I check if A0 is uh, greater than A of 1. Then it means it is not increasing. I say increasing equal to false. Okay. Then what you can do, you can check that, okay, if this is not increasing, then you can put a loop which checks for the array in the decreasing order. Okay. Yes. So now what you can do is that you need to check that, okay, so here what you can do, you can put a if else, that if it is an increasing array, then you check for AI is less than, if AI is greater than AI plus 1, then you will return false. Else you check for the other way around. You check for is AI in a decreasing array, what should happen? If AI becomes less than AI plus 1, then you should return false. Something like that. So basically, we can do it in one loop, or you can put two for loops one after the another. That is also okay. The first loop checks for increasing, the second loop checks for decreasing, right? So you can like write some more logic, but it's not difficult. Okay, so I gave you a hint. So this way is seems better, that you compare the first two elements and you set which direction to check. If you have to check for the increasing direction, apply this check. If you have to check for the decreasing direction, apply this check. Something like that. Okay. So it can be done. You just need to extend this code a little bit, right? So try it yourself. You should be able to do, right. Okay, so let us come back to the problem where we started learning little bit about binary search. So now this is a technique. Yes, Ravindra, that's good. Looks like a cool use of ternary operator. Great job. So it's a technique that can be used for efficient searching in sorted arrays. Okay. So sorted arrays is a one very basic use case. The technique can be applied in more type of problems as well. But right now we are just discussing this use case. That okay. Uh, Given a sorted array and we want to search for an element inside that array. Searching. Okay. So let's see how it works. Let's say I gave you some elements. Let's say 3, 5, 10, 12, 15, 18, 22, 28, and 40. Okay. And let me also draw the indices 0, 1, 2, 3, 4, 5, 6, 7. So the copy paste doesn't work this way, right? Oh, interesting. So now how many elements we have here? 8, right? Great. Let's say I want to search for a particular element. Let's say I want to search where is this element. Okay, 0, 1, 2, 3, 4, 5, 6. Oh, there is a mistake, right? Length of there is 9. So we have 4, 5, 6, 8. So we have 9 elements. Great observation, right? So I want to search for an element, and one way we already know is going to be linear search, right? But what we learned in binary search, I gave you a little bit of idea. So the way it works is that we'll initialize two variables. Let's say one is s, one is e. So start points to the beginning of the array, end points to the last index of the array. So I can say start is 0 and end is array dot length minus 1, something like that. Now what I will do, I will find out the midpoint. Okay, what is the midpoint? Who will tell me what is the midpoint here? Okay, so midpoint is 4. Great. And this is my end and this is my start. So mid I know is going to be s plus e by 2. And what is the element I'm looking for? Let's say the key element that I'm looking for is 28. So now Can I conclude something from the midpoint? If I'm looking for 28, where it must be? To the left of 15 or to the right of 15? Of course, right. Okay. So that means that this part of the array is actually useless. Okay. So now what we do, we reduce this part and we bring our start here. We say, okay, at what condition? We said that if array of mid is less than the key element, then the key element must be present on the right. So where should my start code should go to mid plus 1. So now what array do I have? I only have this part of the array. Yes or no? I only need to search in this part of the array, right? So now what we will do, we'll again find out the midpoint. The new midpoint will be what? It is going to be 8 plus 5 by 2, which is 6, right? 6. So this is the new midpoint. And again, we have to make a comparison. So we are looking for 28. Okay. We are looking for 28. So where we should go? We should again go right. So we can check that if array of mid is less than key, then we will go right. So our start will now come here. Great. So this is the new start, and we'll discard this part of the array. So this part is now useless for us. So that means now we have this array. Start is at 7, end is at again 8. So we have 28, we have 40. The new midpoint is what? 7 plus 8 by 2, which is 7. That means mid is here. So what happened in this case? We are looking for 28 and we have reached 28. So if array of mid equals to the key, what should we do? We should return mid. We should return this element. Yes or no? That is what we should do, right? Okay. So in this case, it will terminate, right? But let's have a case where we are not searching for 28. Let's say we are searching for the element that is 18. So let's see how this entire thing will happen in that case. Let's say we are searching for the element 18. Okay. So now again, first step is to find out the midpoint. So midpoint is going to be 4, and we know that 18 is in the right of, right, 8 is in the right of 15. So we know that array of mid is less than our key element. So we say, okay, start equal to mid plus 1. So we discard this part of the array and our start goes here. So start goes to mid plus 1. So now start is here, right? So what is the new midpoint? 18, 22, 28, and 40. Start here, end is here. The new mid is here, right? If you do 4 plus 8, that is 12. 12 by 2 is 6. So 5, 6, 7, 8. So the new midpoint is 6. Now what is happening? We are comparing 22 with 18. So now 22 is not less than 18. So 22 is actually greater than 18, right? So we have a case when array of mid is greater than the element that we are searching for. What should we do in this case? We should shrink our search space such that now this part is useless because if 22 is greater than 18, then all limits to the right of 22 are also greater. So we discard this part and we bring our end here. So we say, okay, end is equal to mid minus 1. Great. So now again, we have a start here, we have a end here, and we have a 18 here. So now what is the new midpoint? It's the same number. So midpoint is start is 5, end is 5, mid is also 5. And we will hit a case that okay, if array of mid is equal to key, I will return the midpoint. Got it? So are you understanding what is happening? In every step, the array size is getting reduced by 2. Initially the array size was n. In the next step it was n by 2 because you discarded half of the array. In the next step it is n by 4. So in how many steps the array size would become 1? So everyone is saying log n. Absolutely correct. So we discussed that if something is decaying like this, we can say okay, it will take log n steps to become 1, right? How about s is equal to mid instead of s is equal to mid plus 1? So you can do it, but that doesn't make a lot of sense because uh, you know that if 18 is present it and it is not, it's greater than 15. So it's better go right of 15. Okay. So when you know that it must be on the right, then why you should put s here? So it's better to put it here. Okay. It's not wrong, but still. Okay. So we have not discussed one case when the element is not present. Yes or no? We have not discussed if the element is not present. So let's see what happens. Let's try to search for an element which is, let's say, 14. Chirag, which is the extra step? Right, right. So what we will do is we will use actually in our code we will use something like if followed by else if followed by else, something like this. Okay. So one for greater, one for lesser, and one for equal. Something like this. We'll do. So we have three cases. That is what I'm trying to tell you, right? So let's try to search for an element. Let's say we are searching for the element 9. The key element is 9. So again, we find out the midpoint. The midpoint is 4. So I know if 9 is present, it must be on the left of 15. So what I do, I discard this part of the array. So where does my end come? So my end comes here. Okay, now I have this much array to work with. 3, 5, 10, and 12. What is the midpoint? This is the midpoint, right? Yes or no? So now I'm looking for 9. If 9 is present, it must be on left of 5 or right of 5. Of course, right of 5. So this part is useless. So my start goes here. So my start goes here. Okay. So now I am at S is at 10 and E is at 12. So these numbers are 2, 3, right? What is the midpoint? So this is the midpoint, 2 plus 3 by 2. Okay. So I'm looking for 9 and currently my mid is 10. So what is the condition? That if the middle element is greater than key, where do we go? We go end equal to mid minus 1. So we apply this update. In this case, we apply this update that end is equal to mid minus 1. So start was here, end was here, we mid was here, right? So effectively what we did, we applied this update that end should go here. Okay. So effectively end came to this index and start is here. Now what we can say about this kind of a scenario where the value of start exceeds the value of end. So start was going like this, end was going like this. So we came to a point where start exceeded the value of end. So what does it mean? Of course, it means if you hit such a scenario, that means if start becomes greater than end, then the element is not present. Element is not present. Right. Now, how do we code this up? Let's write a function. Let's say int binary search. Yes, Chirag, we will do it. Okay. So Sheetal says, don't we get a array out of bounds exception? So Sheetal, we are not saying array of E or we are not saying array of S. We are just talking in terms of S and E. They are numbers. And out of bounds you can get only if you are hitting an index which is actually out of bounds. In this case, it's not hitting out of bounds, right? Plus, you are not accessing the element. You are not accessing a value at this index, right? You are simply saying that put E is equal to S minus 1. That's it. Okay, let me show you in the form of pseudocode how we are going to do it. So you will have a function int binary search. You get a array, and that's it. That's what you will get, and you'll also get the element to search. Let's say key. So in the beginning, you can say okay, s is 0, end is array dot length minus 1, and then you can say while what. So I want to binary search till what point? What should be my stopping condition? Should it be s greater than e? Should it be s less than e? Should it be less than equal to e? Or should it be s greater than equal to e? See, we need to stop the loop when the element is not present. Okay, so that means the loop should stop when this condition is achieved. Okay, so that means this is the condition when the loop should stop. That means the loop should run while s is less than equal to e. जब तक ये कंडीशन ट्रू है तब तक हमारा लूप चलता रहे, right? So the loop should run till this point. This condition is true. So when this condition becomes false when s becomes greater than e, and that means element is not present. Okay, the element is not present. So false would mean you will go out of the loop, and here you can say okay, print not present, and you can say okay, return minus 1, which is a invalid index, something like this. Okay, so whatever is the work that you will do inside the loop, so let's focus on that work. So first thing is you will find out the midpoint. So midpoint is s plus e by 2. Then you will compare if array of mid, if it is greater than key, what we should do? Who will tell me? If array of mid is greater than key, where should my, what should be the update? Let's say we are at 15 and we are looking for 8. So array of mid is greater than key. What should change in this case? End is equal to mid minus 1. Okay, end is equal to mid minus 1. Else if array of mid is, let's say, equal to key, What should I do? I should return the middle index. Else, what should I do? Start should go to mid plus 1. So we have the three cases which we have written inside the loop. So every time we are computing mid, we are checking is it greater, is it equal, or is it lesser. So we have the three cases. You can write the cases in any order, and that's it. So if we come out of the loop, that means the element is not present. Now I am interested in finding how many times this loop is going to run. So see what happens. We have start and end. Then let's say start goes to mid plus 1. So we get this part of the array. Okay. Next time maybe end goes to mid. So we only get this part of the array to work with. So initially it was n, then it was n by 2, then it was n by 4. So eventually it would become only one element. So in how many steps it will become 1? So we have already discussed that this loop will run for log of n times. Okay. And hence the time complexity of binary search is order of log of n. What about the space complexity? It's order of 1. Great. We are not using any space that is proportional to n, and hence the space complexity would be order of 1, right? So Darshan says why s is less than equal to e instead of s less than e. So Sudarshan, when both s and e they are pointing to the same element, right? That is a valid case. We should still check. The loop should still run and make comparisons when both start and end they are pointing to the same element. For example, uh, let's say both s and e they point to an element 9, and you're looking for an element that is 9. So your mid might be the same element, and you want to compare, okay, is this mid equal to key? We can check that after the loop exits. See, you can do it like, uh, but why write a separate if condition if it is already can be handled inside the loop, right? Outside the loop, we will check if s is greater than e, only then we will say key is not present. So no, that's not required, because you have already put a return statement inside the loop. If it is present, you will always return from this point without coming out of the loop. You will directly go out of the function. Okay. So for unsorted array, linear search is the only option. Yes, for unsorted array, it's the only option. For the same question, if it is not sorted, we will sort the and binary search. Then the time complexity will be n. No, that's not true. See, if the array is unsorted and the question is about finding the position of a particular element, let's say, and you say, okay, I will sort it. So you, let's say you make it as 1, 3, 5, 6, 8, something, something, or whatever it is. Which element I left? 1, 3, 5, 6, 8. Oh, there are two threes, right? Right, right. So now if you sort it, so there are two things. In the original question, what was the position of this element? So the index was 3. But now if you search in this array, what is the index? The index is now 0. So that means it will lead to wrong answer. Okay. And secondly, the time to sort generally an array is n log n. If you use some kind of inbuilt function, and then if you perform binary search on it, it will take order of log n time. That means if you do sorting plus binary search, you are not making your answer wrong. Like you're giving wrong answer, plus the time that you're taking is order of n log n plus log of n, which can be written as order of n log n. Okay. So I'm not discussed the time for sorting yet, but I'm just telling you that the time to sort is n log n. But if you do linear search directly, it will be still order of n. So that means linear search is both better, and it not only gives you the correct answer, but it takes less time than sorting. Okay. So sorting is not O of n, it is n of log n into log of n. Okay. That is the time that you need to sort an array. Quick sort, merge sort, heap sort, whatever sort it is using, it's going to take n log n. Can we search in a string in an array using binary search? Yes, of course. Let's say we have uh, an array of string. Let's say we have, uh, but the only thing is the array should contain strings in a dictionary order. For example, if you have apple, bat, batman, cat, okay, uh, catty, something like this. Now, if I'm saying, okay, I'm looking for the word cat, so you give the start, you give the end. Now, this array is sorted. If you compare the words, they are appearing in a dictionary order. So, if I have a cat, I'm compare this cat with the midpoint. So, of course, Batman is less than cat. Why? Because the comparison between two strings, it happens according to the dictionary order. So cat comes after Batman, so cat is bigger, and hence you go right. This becomes your start. Then you again find out the midpoint. Then you again make a comparison. You check, is this equal to cat? The answer is yes, and you return, right? So are you getting it? You can apply this on an array of strings. No, it's not a character array. It's a array of strings. Okay, something like this: string array, some names. Okay, something like this. It's an array of string. Can we do binary search on a character array? See, any data that is how to compare strings. Okay, let me show it to you. I think the direct operator should work. So the operator should know how to compare two strings. Otherwise, there must be some function. Let's see. Rishikant, we do not need to iterate over every character in that. You either you can make your own comparison function or you can use the inbuilt one, right? So let me try to answer it. Okay, Rishikant says compare to. Let's see. Okay, I don't remember, but let's say string A is Batman, string B is cat. For equals, I know it's equals A dot A equals B. Okay, A dot compare to, right? So there is a function called compare to. I can say okay, S out A dot compare to B. So this function I think would return a positive number, a negative number, or a zero. So negative number would mean that the string A is smaller. Okay, but if I say okay, if string one is also cat, then it will return zero. Okay, because both of them they are equal. Or if this is a dog, that in that case it will return a one, that the string dog is greater than cat. So you can use the compare to function. Okay, so the compare to returns 1 0 and minus 1. Okay, so 1 if A is greater than B, 0 if A is equal to B, and minus 1 if A is less than B. That's it. Okay, and you can also write your own compare to function, right? It will compare, ask a value of the first letter of each string. So suppose if it is, let's say, bat versus Batman. So which one is going to be bigger? So it's going to compare B with B. It's equal, so it's going to go to A. A and A, they are equal. It's going to compare T and T. It's equal. Now this string has ended, but we still have something here. So in that case, it will say that okay, this one is bigger. Okay, but suppose you have something like uh, cat and you have something like cab. So it's going to compare C and Z, they are equal. A and A, they're equal. Now between T and B, which one is smaller? So of course, the B is smaller. Okay. So the first place where there is a mismatch, it's going to decide upon that. And if you look at the dictionary order, we know that cab will come first, and then the cat will come. Then the word catty will come. So exactly the output will be based upon the dictionary order. Okay, got it? Got it. Great. Okay, so what we'll do is we'll stop for a short break, and then we will resume after the break. Okay, so let's have a 10-minute break, and we'll start at 10:15. Sheetal, can you refer the exact question, or you can paste in the chat? Okay, so Sheetal has a doubt. So for I equal to n, I greater than 0, I equal to I by 2, we have for loop here, j equal to 0, j less than I, and j plus plus. Okay. So now we need to count what is the total work these two loops are doing together. So let me tell you, right? Now in this case, you cannot See, whenever you have something which is a variable, right? So the inner loop is running how many times? It is running variable number of times. It is not fixed. Okay, so in some cases it is constant. In some cases it is like j is less than equal to n. J goes from 1 to n. So you know it always runs n times. So in this case it's a constant. So whenever you have this thing as a variable, you cannot multiply the number of times the outer loop is running with the number of times the inner loop is running. Okay, so you cannot do it. So you have to go with the fundamental approach. So what is the fundamental approach? The fundamental approach is about counting the total work done. So now if I have the value of I that is equal to n, so can you tell me how many times the inner loop is going to run? Just for I equal to n, it's going to run n times. Great. That means your work will get done n times. So next time, what you're doing, you're saying I is equal to I by 2. Okay. So your I becomes n by 2. And how many times your loop is going to run? Inner loop, n by 2 times. Okay. Next time I is going to become n by 4. How many times the inner loop is going to run? N by 4 times. So eventually I would become 1 and then I would become 0. So when I becomes 1, the inner loop will run one time. Do you agree? Something like this. So what is the total times the work is getting done? So this is what is happening in each iteration of the outer for loop. So these colors are denoting one iteration of the outer for loop. So if I sum up all the iterations of the outer for loop, how much it would be? So it would be nothing but n plus n by 2 plus n by 4 plus up to 1, right? Now I know these are log n terms. The number of terms, see, number of steps is log n, but the total work is not log n. Why? This is the total work. So if you sum it up, you take n common, you get 1 plus 1 by 2 plus 1 by 4 plus up to what? So you multiply this with n, you divide this with n. So n is common, so you get up to 1 by n, right? And we discussed that the sum of this series is approximately what? It is a GP, right? It is a GP. It is a GP formula. So we can say that A into R raised to the power n minus 1 upon R minus 1. So it is n into uh, A is 1, R is 1 by 2 raised to the power n minus 1 upon 1 by 2 minus 1. So this is constant, we can ignore it. So it will be n divided by 2 raised to the power n. Uh, yes or no? So what is the correct answer that was given in the question? Sorry, this should not be n, right? Sorry, this should not be n. I made a mistake. The number of terms, right? The number of terms is not n. The number of terms is log n. So we have log n terms here. So it will be n is the number of terms. So it will be 1 by 2 raised to the power log of n upon 1 by 2 minus 1. So that is constant that we can ignore. Can you explain the last step? Okay, so I will tell you that I think I might have made a mistake in the calculation in the previous class, but let's see what this turns out to be. See, this is a GP, right? This is a geometric progression where you have the first term as 1, the subsequent terms is having a common ratio of 1 by 2, right? And we discussed that sum of n terms of GP is given by a raised to the power n minus 1 upon r minus 1. This is what we did. Okay, so if you have n here, so a is 1, r is 1 by 2 raised to the power n minus 1 upon 1 by 2 minus 1. So you can take minus common, it becomes n divided by 1 by 2 into 1 minus 1 by 2 raised to the power n. So here n is the number of terms in the series. So how many terms we have? We have log of n terms. Okay, so let me Google it up. So see, we can ignore minus 1, that's okay. 1 minus 1 by 2 raised to the power log of n. Okay, let us uh, no, I think the sequence that we googled was something different. It was 1 plus 1 by 2 plus 1 by 3 plus 1 by 4. I think this was the sequence that we googled up last time, and this sequence was log of n, right? Here the sequence is little different, so that might have led to the confusion. So we don't have terms like 1 by 3, 1 by 5, right? So this was a different sequence. Okay. Okay, I will tell you one thing. Let us try to overestimate this value. So let's say that this log n is, let us assume that the number of terms is infinite. Okay, and I know log n would be, of course, it would be much more less than infinity. Okay, so can we use this formula that if the number of terms is infinite, so we are basically overestimating. In order to simplify our work, we are overestimating. So we said we knew that if we have this series where we have 1 plus 1 by 2 plus 1 by 4. So instead of going till log of n terms, let me go till infinite terms. Even if I have infinite terms, what is the sum of this series? It is a upon 1 minus r. This is what we discussed. Yes or no? So now if I just put this formula here, so that will give me a simpler expression. So what is A? A is 1. What is R? It is 2. So 1 minus 1 by 2. So this sum actually sums up to 2. So what you get? You actually get this to be less than equal to 2 of n. That means it is still order of n. So order of n is the correct answer. So forgive me if I made a mistake in the last class. This should be the correct answer. So the time complexity of the following code, it should be order of n. Gangadhar, are you happy now? Was this the answer given? Right. Right. So great job. So we just got confused because of this series. So this is not a GP. It's something called as a HP, harmonic progression. Okay. It is harmonic progression. Mupa says, can you explain the last step? So Mupa, what I'm saying is that I don't want to do this calculation. It's getting a little complicated. I don't know what is 1 by 2 raised to the power log n, but it would be a very small number. Okay. Consider the outer loop. We are considering the outer loop, right? We are considering the outer loop. I'll give you an example. Okay, I'll give you an example. Let's say uh, n is, let's say, 100. So when n is 100, the inner loop is running how many times? It is running 100 times. So what I'm saying is that together both the loops will run less than 200 times. So I'm saying the answer, the number of iterations would be always less than 2 of n. Okay. So when let's say n is 100, the inner loop runs 100 times. So that means this work gets printed 100 times. So when n is 50 in the next step, the inner loop runs 50 times. Okay. Let's say n becomes 25, the inner loop runs 25 times. N becomes 12, it runs 12 times. N becomes 6, it runs 6 times. N becomes 3, it becomes 3 times. N becomes 1, it runs 1 times. N becomes 0, the outer loop stops, the inner loop also stops. So can you tell me what is the total? How many times this loops print, these two loops together did the work? Can anyone tell me the total? So 100 plus 150, 175 plus 12, 187 plus 6, 193 plus 3, 196 and 197. So that is what I'm saying, that I told you in the beginning that for given n, these two loops together will run less than 2n times. And how do we got that? How do we got that? We got that through this mathematical proof that we just did. Okay. So we said we are trying to find out the sum of the series n plus n by 2 plus n by 4 plus up to 1, right? So we take n common, so it becomes 1 plus 1 by 2 plus 1 by 4 and so on. Now this becomes a GP. Let us assume that there are infinite terms in the GP. Whatever is the number of terms, if it is log n or it is n. So right now I know it's log n terms, but let us assume that there are infinite terms because infinity is of course greater than log n. So it is always okay to overestimate, but not to underestimate. So what is the sum of an infinite GP? So it is given as A upon 1 minus R. This is one formula I told you. So what is A? The first term. Okay. What is R? It is 1 by 2. So 1 minus 1 by 2. So we got 2 of n. So did you understand this now through this example? Okay. So that's what I said. It's going to be less than 200, less than 200, 200. Okay. 2 of n. So which is still order of n. Okay. Got it. So the sum of GP is 2n. Yes, in this case it is 2 of n, right? It is 2. Sum of GP is 2, right? And the time complexity is O of n, right? Because we ignore the constants. Okay, so now maybe let us stop for a break, and Kuldeep says in which case it will become log n. So Kuldeep, if you have any loop which is running like this, let's say I equal to 1, I less than equal to n, and you're saying I equal to I by 2, I into 2. So now how many times this loop is going to run? Log of n times. Okay, and suppose you have something like j goes from 1 to n always, and you have j plus plus, something like this. So now how many times this loop runs? Always n times, right? So if you talk about what is the total work they are doing, so it will be log n into n. Okay, or if you interchange the loops, then also it will be log n into n. Okay, or if you have I equal to n, I greater than 0, I equal to I by 2, that is also log of n. Okay, so together it would be n into log of n. So in this question, both the loops were running variable number of times. So j was not dependent upon n, it was dependent upon I. So that is why we had to do all this calculation. It was a variable thing, it was not a constant. Okay, so let's connect at 10:32. Let's give you the break again. Okay, Rishikant, I'll give you a chance after the break. Okay, so let me have some water. We'll continue after break. All right, so welcome back. Uh, I'll give you a question to think, and you have to tell me, right? So the question is very simple: that given an array that contains n elements, given an array containing n elements, so you have to count the number of elements having at least one element greater than itself. So what does it mean? Who will decode the question for me? Let's say I have an array where the elements are, let's say, -3, 2, 5, 8, 6, 7, 8, 10, -2. Okay. So now what is this question saying? Given an array containing elements, count the number of elements having at least one element greater than itself. Now suppose I talk about an element 2. So there is an element which is greater than 2. So there is at least one element which is greater than 2. So yes, I will count it. So how I should solve this question? Okay. No, no, we are not given 2. We have to count all the elements basically. Checking each index and comparing, right? So one option could be, see, now there can be multiple algorithms to do it. So let's try to build a algorithm first. Let's say we go to every element. Go to every element. Okay, let's say, and I go to some element -3, and then I iterate over the remaining array to find, is there an element which is greater than -3? Yes or no? And iterate for the remaining array. That means for all indices 0 to n minus 1 except I, to find a greater element. Okay. If a greater element is present, then you increment the count. If it is not present, then you don't increment it. Yes or no? So what would be the time complexity of this approach? How much time it will take? Okay, so what you're doing, you're saying that, okay, I'm going to go over every element from 0 to n minus 1, and then I'm going to find a greater element for array of I. So I'm saying for, again, go from 0 to n minus 1 and find the that greater element, something, something, some conditions here. So of course, this is how the code would look like. Yes or no? Right? So it would be order of n square. Can we do better? Can we do better? Like Chirag says, why do we need two loops? So, Chirag, you go to -3, then you iterate over this array, Is there an element which is greater than minus 3? The answer is yes. Then you go to the next element 2. Then you again iterate on this array to find an element which is greater than 2, which is in this case 5. So in the worst case, you are going over the array again and again. Okay. So this is of course it's a bad approach. It's not good. Can we do something better? Yes, key is the number. Itself means every number. Okay. So people are saying binary search. People are saying key is not provided. Yes, key is not provided. We every number is the key, right? Okay. Another option could be that what we can do. So let us see what are the numbers. Okay. So now, uh, so people are saying let's do sorting and stuff. Okay, let us do sorting. So what happens after sorting? So maybe after sorting you get something like this. You get minus 3, minus 2, 2, 5, 6, 7, 8, 10. Let's say you did some sorting, and then you know that every element will have a number greater than itself. Yes or no? Except the last number. Okay, except the last number. Okay, maybe let's say 10 is occurring 3 times. So you will have 10, 10, 10. So now you cannot directly say uh, 10. You can yes, duplicates can be present. Okay, because 10 is a number which does not have an element which is greater than itself. So minus 3 has an element minus 2, minus 2 has an element 2, 2 has an element 5. So all these elements have at least one element greater than itself. But now the number 10 does not have any such any such element, right? So now, so we did sorting, and now what we want to do? We want to find out the first occurrence of 10. We want to find out the first occurrence of 10. Now how do I search for the first occurrence of 10? How do I get where is this first 10 present? Who will tell me? How do I find where is the first 10 present? Okay, now there are three ways to do it. So one way is we do a linear search. Okay, so linear search would mean that I have to take order and time to search it. Since this array is a sorted array, we can do binary search also. That means it will take log of n time. Yes or no? So we have something called as a modified binary search, which gives us the lower bound. So I've not taught you that, but we can modify binary search a little bit to get the first occurrence. Okay. And the third option is people are saying that it would be n minus the count of 10. Someone said this. So again, how do you count 10? It is going to be, let's say the count is going to be 3, but how do you know it's 3? That is the question. So again, you have to iterate it linearly. You will say, okay, order of n. But I told you that sorting is an expensive operation. So sorting itself takes order of n log n time. If you build a efficient sorting algorithm, it takes order of n log n time. So all these times are going to get added. So what would be the overall complexity? Order of n log n plus log n and order of n log n plus n, which is better? So both are same. Both are same, right? So both are order of n log n because we ignore the lower terms. This also does not seem like a very good algorithm But we got a hint. We got a hint that if we know the biggest number, then right. So Rishikesh is now getting the point. So what the question is actually about finding is that if I know that how many times the largest number is present in the array, that will solve my problem. That itself will solve my problem. Are you getting it? I don't need any sorting. I don't need any searching. I just need to count how many times the largest number is coming in the array. Rest all elements will have at least one element greater than them. Are you getting it? If I just count, okay, there is a 10 here, there is a 10 here, there is a 10 here. How many tens are there? There are three tens, right? So if I just see what is the largest number and how many times it is coming, my work is done, right? So what is the algorithm? What are the two steps we need to perform? The first step is find the largest number. Okay, how do I find it? Again, I write a loop from 0 to n, and I say okay that largest is some smallest number minus infinity. If array of I is greater than largest, then I say okay largest is equal to array of I. This is how I do it. So this code is order of n. Okay, the second step would be what should be the next step? Count, right? Counting how many times this is coming. So for counting, since there is not sorted, we can use linear search. Okay. So we can say, okay, for again, I equal to 0 till n, if array of I, if this is equal to largest, I do something like count plus plus. So count was initially 0. Okay. So this code is again order of n. And finally, what will be my answer? What will be my answer? So out of total elements, subtract the occurrences of the largest number. That will give me the answer. Yes or no? So if n is 10, count is 3. So there are 7 such elements which have at least one element greater than itself. So the overall complexity would be what? So n plus 1. So it's going to be order of. Okay, so of course the third algorithm is the simplest and the fastest. Got it? Uh, so Sudarshan says you can do both in the same loop. Can we do the same thing in the same loop? Sudarshan, we don't know the largest number. We don't know the largest number. Whose count you will update? Okay, so let me dry run this a little bit if it is not clear. Let's say the elements are minus 3, minus 2, 6, 8, 4, 8, and 5. So firstly we say okay I don't know the largest. The largest is let's say minus infinity. I go to minus 3, I make it minus 3. I go to minus 2, I make it minus 2. I go to 6, I make it 6. I go to 8, I make it 8. I go to 4, but the largest does not change. I go to 8, largest does not change. I go to 5, the largest does not change. Now after one iteration I know what is the largest. In the next iteration I say okay is this number 8? No. Is it 8? No. Is it 8? No. Is it 8? Yes. So I make count as 1. Is it 8? No. Is it 8? Yes. So I increment the count and make it 2. Is it 8? No. So finally I know the count is 2, right? If we keep the count of current largest number and reset if the largest number changes. If the largest number changes. Mm, let me think upon it. You got 8, you updated the largest as 8, and you said count is equal to 1. Then you got 4, uh, then you got another 8, which is equal to largest. I think maybe we can do something like this. What Sudarshan is saying. Sudarshan is saying that so if I get AI is greater than largest, then we say okay, largest is equal to AI, and we say count is equal to 1. Okay, and if I get that AI is equal to large, else if, not if, else if AI is equal to largest, then Sudarshan is saying count equal to count plus 1. Is this what you are saying, Sudarshan? Now it might be correct. Let's try to do a dry run. Who all understood this algorithm? What Sudarshan has said. So this is another way. Good job. So we actually combined the two logics into one, but still the complexity would is still same. So let's have an example. Let's say 2, 3, 5, 8, 5, 8, 10, 10, something like this. So now I'm going from, let's say, 6. Let's say largest is, let's say, minus infinity. So I run this. I go to 2. Largest is 2. So largest is 2. Count is 1. Okay. Then I go to 3. The largest is 3. The count is still 1. I go to 8. The largest is 8. The count is 1. I go to 5. Largest does not change. And this condition is also not true. I go to 8. Now 8 is not greater than 8, but AI is equal to largest. So I increment the count. So I increment this count to be 2. I go to 10. 10 is the largest. So I say, okay, largest is 10 and count is 1. So this count becomes 1. I go to 10, which is not greater than 10, but it is equal. So I say count is also 10. Okay. And I go to 6. So it does not change. So finally, I have 10 as the largest and count as 2. So yes, we can do it in one loop, which is fine. Okay. Now talking about the complexity. So how much is the work that we are doing? So we are doing n iterations. So work is proportional to n, and hence it is order of n. Okay. So that is the benefit of peer learning. So Sudarshan thought something which I didn't think, but now it's proved that Sudarshan's solution is correct. Okay, so we can do it, but nevertheless, the above solution is also not bad. We are using two independent loops. We are not using two nested loops. So this is one loop. When it is over, we run the second loop. So they are not nested. So in this case also, it is order n plus n plus like 1. That is the constant work that we are doing. So it's still order of n. Okay. So 2n is also order of n, which is fine. So both the solutions are acceptable and both have same time complexity. Any doubts in this one? No doubts? No, no. Here the largest was 10, right? The largest was 10. So the output would be 1, 2, 3, 4, 5, 6, 7. Out of 9 numbers, we have two largest numbers. So 7 would be the final output. We have to count the number of numbers less than the largest number. That's it. That was the question. Okay, tell me one thing. Again, I need your help to recall. Did we solve this problem? Pair sum. Given an array, you have to find out a pair whose sum is equal to some given number. Okay, it was an assignment. Okay, people are saying we have not solved it. So let us discuss then. Okay, let us discuss. Okay, so now let me give you something. Let's say, uh, given a sorted array. Okay, let's say you're given a sorted array, and we want to find out a pair of numbers such that their sum is equal to, let's say, 11. So this is given as input. So this is input, this is input. Got it? Okay. We did it in the class. So if we did it in the class, did I discuss this two pointer technique? Start from left and right. The two pointer technique. Okay, fine enough. If it is already discussed, so we will not do it again. Okay, so just go and recap the class. So I told you that, okay, you can one way is you can use two loops. You can use two nested loops. That, okay, for every element. Rishikant says please do it. Okay, so let me just give you a quick recap. So one way is you pick every element. You say, okay, I'll pick every element starting from the zeroth element till this element, which is n minus 1, and I will try to combine this element with all possible options. So one with 3, one with 5, one with 6, one with 10, one with 12, one with 15. Okay, so for every element, then I will pick 3 and I will try to combine with every other element. 3 with 5, 3 with 6, 3 with 10, 3 with 12, 3 with 15, and so on. Okay, then I will pick 5 and I will do the same thing. 5 with 6, 5 with 10, and so on. So what I'm doing, I'm picking every element and I'm saying, okay, let us try to combine this with every j. So j starts with I plus 1 till the uh, last element. Okay, and I check if ai plus aj, this is equal to sum, then I got a pair. Okay, so whatever is the pair, you print that. So of course, this solution is going to take how much time? This is what we did. Okay, so we did this already. So this will is going to be order of n square, of course, right? It's going to be order of n square, and it's not the best way of doing it. Not the best way of doing it. Okay. So now, what else can be done, right? So right now we are not exploiting this information that the array is sorted. It's given that it's a sorted array. Okay, so we want to exploit this information. So right now what we did, we tried out all possibilities. Okay, all possibilities, but we now want to play smart. So this is algo 1, and let me do algo 2. So what could be a better way of solving this problem? Let's see. 1, 3, or let me just copy this array. Surprisingly, it cannot be copied on another page. Oh, now it's okay. Okay, let me do something like this. Let me say what happens if I add the first number and the last number. So my goal is to reach a sum that is 11. Okay, and what if I add the first number and the last number? So this is area of start, this is area of end. So if I do AS plus AE, what do I get? I get a number that is 1 plus 15, that is 16. Okay, now there can be two options. Either I increase the leftmost number or I decrease the rightmost number. Okay, so now my sum is greater than my goal. So what number should I change? I want to decrease this sum. That means the only way I can decrease this sum is by bringing this end pointer here, by bringing this end to here. So I say, okay, do something like E minus minus. Okay, so again I do AS plus AE, so which is now 1 plus 12. It is 13. It is still bigger. That means there is no other possibility. Again, my sum is greater than goal. So why not S plus plus? Why not S plus plus? So Ankur, see, if you have 1 plus 15, right? And you are getting 16. You want to reach a number that is 11, right? So if you increment this S, so if incrementing S would increase the sum, right? Try to understand. Incrementing S would increase the sum because the array is sorted. Whereas decrementing E would decrease the sum. Yes or no? You're moving towards a smaller number, right? So we have to, again, we got 13. We want to get a sum that is 11. So what should I do? I should say, okay, let us reduce E again. I reach here, okay? So I reach a value that is 10. So I say, okay, AS plus AE, how much it is? It's 1 plus 10, that is 11. Oh, great. We got something which is equal to the goal. Now it means, what should I do? What should I do in this scenario? I should print, okay, I should print 1 and 11. I got a pair. So I do print the numbers at S and D. So I print AS and AE. I don't want to stop. I want to print all the pairs. Maybe I'm not happy with the current pairs. I want to do it again. So what I should do? Because I already used 1 and I already used the number 10. So what should I do? I should ignore both. So that means I should do S plus plus and I should also do E minus minus because both of these numbers are used. So S comes here and E comes here. So what happens? AS plus AE is now how much? It's going to be 3 plus 6, that is 9. So now 9 is less than goal. What should I do? Should I decrease E or should I increment S? I should increment S because I want to increase the sum, right? I don't want to decrease it. So I do S plus plus. I come here. So what is AS plus AE? It's 5 plus 6. It's going to be 11. Again, I got a pair, so I will print. So sum is equal to goal. So I print the numbers 5 and 6. And again, I do S plus plus and E minus minus. So S goes here finally and E goes here. So what should I do? The value of S is now greater than E. The value of S is now greater than E. What should I do? I should stop, right? So if who will tell me how do I write this loop in the form of a loop? While S is, let's say, less than E, we don't even want equal. I don't want to repeat the same number, right? Find out the sum. So sum is AS plus AE. If sum is bigger than goal, you do E minus minus. Else if sum is less than goal, you do S plus plus. Else if it is equal, you print AS AE and you do s plus plus, and you do e minus minus. That's it. And that solves your problem. Understood? Why not equal? Because I don't want to use the same number two times. Okay, I don't want to say 5 plus 5 is 10 or something like this. So we got a doubt by Deepti. What if there are duplicate elements? Hmm. How do we handle duplicates? So what are your ideas on duplicates? Let's say 1, 1, uh, 3, 5, 6. Okay, let us first talk about the time complexity. How much time it is going to take? So this is a simple for loop. In the worst case, what we are doing, we are iterating. This S is going, this E is coming. So effectively, both S and E, they are covering a distance of n units. So this loop will run n times, and hence it's going to be order of n. So we have already optimized from n square to order of n, and it's a good optimization that we did. Okay, so this technique, it is known as two pointer technique. It's known as two pointer technique. So Chirag says if it is not sorted, then n log n plus n. Okay, let me take up all these doubts. Okay, sorted is fine. If it is unsorted, okay. So let's say 3, 5, 1, 2, 7, 6, 5, 8. So if it is unsorted, let's say, then what you will need is one thing you can do is you can first do sorting, and then you can apply two pointer. Okay, so sorting would mean n log n, and two pointer would mean n, so it would become order of n log n. Okay. That being said, there is something called as a hash map. Okay, it's a data structure which we have not covered yet, but we will cover in the intermediate batch. Okay, so what is this hash map? So using a hash map, what you can do, you can maintain each element and its frequency. You can say, okay, 3 is coming one time, 5 is coming one time, 2 is coming one time, 1 is coming one time, 7 is coming one time, 6 is coming one time, and so on. Okay, so now what you can do, you can say, okay, I am at 3. Is there a number that I can add to this 3 so that the sum becomes 11? Okay, so what should be that number? 8, right? So now how do I search for this number? So right now we were doing a linear search, okay, or we were doing a two pointer thing. So instead of doing linear search, we will do something called as a hash map lookup. We'll ask this table, is there a 8 present, and if it is present, then how many times it is present. So it will tell me, okay, 8 is present one time, so I'll get a pair 3 comma 8. Okay, so this is actually a constant time lookup. Okay, so hash map is a data structure that can help you to find things in constant time. Okay, extra space is needed. Yes, of course we need extra space. So it comes at the cost of extra space, which is order of n space, but it can help you find things in constant time. So that being said, it is a topic. What is the time complexity of searching in hash map? So order one. Okay, so it gives searching in order one. So you do O1 search. So with 3 you spend constant time, with 5 you spend constant time, with 1 you spend constant time. So what number should I add to 5 so that the sum is 11? So x is 6, so I'm looking for 6 in this table. So that constant time will add up how many times? How many times? N times, right? So if you do a hash map uh, approach, you can solve this in order of n time for unsorted array. Okay, for unsorted array. So that being said, let's not worry about what is a hash map, how to implement it. So we'll definitely cover it. It's a topic of upcoming classes. Okay, so having a hash map will solve this problem for both the cases, when we have duplicates and when we have unsorted array. Okay, because hash map is going to maintain the count of the number which is present in this array and how many times it is present. Okay, so with hash map both of these problems can be solved, and the pair sum problem can be solved in order of 10 times. So I just gave you a quick idea. It's okay if you got a little bit of intuition, but right now what you should understand is the two pointer technique. Okay, so let me know if it is clear. Chirag says forgot. What forgot already? Okay, hash map. Okay. So we will do it in upcoming classes, not in today's class. Okay. So you're multiplying n with n log n, right? So see, I told you two algorithms, algo 3 and algo 4. So algo 4 uses hash map. Hash map may we don't need sorting. No sorting is required. But if you do sorting and then you apply two pointer, then it will be order of n log n. But if you simply do it using hash map, it will be order of n. Okay. So there are two techniques. One uses hash map, one uses sorting. Two pointer technique requires the array to be sorted. Yes, it will require the array to be sorted. Any other way to optimize without hash map? No, there is no other way. Hash map seems like cheating. No, no, it's not cheating. It's actually a very powerful data structure and it's used a lot. Okay, it's used a lot. So let me know if you have any doubts from today's class or anything you did not understand. We can give you a quick recap. Otherwise, we are almost done for the today. And yes, two pointer will require a sorted array. Yes. Okay. Rajesh says algo 3. Uh, is algo 3 not clear, Rajesh? Okay. So Rajesh, given an array, let's say 2, 8, 4, 6, 2, and let's say 0. So I want to find out how many pairs are there so that their sum is equal to 8. So right now I cannot use two pointer technique here. So if I say s plus e 2 plus 0 is 0, so I don't know whether incrementing s would increase my sum or whether decrementing e would increase my sum. I don't know in which direction should I move. Okay, so I told you that you first sort it. So sorting would mean it becomes 0, 2, 2, 4, 6, 8, let's say, and let us assume there are no duplicates. So 0, 2, 4, 6, 8. So you say okay, start and end. So s plus e is 8. You got a pair. You take your s here, you take your e here. Oh, you again got a pair. 2 plus 6, it's 8. Right? So I told you that the first step is sorting, and then you apply the two pointer approach. Okay. So sorting would take order of n log n time. We have not proved it. This is something you can remember as of now. Once we do sorting algorithms, we will prove it. Okay. and 2 pointer I told you takes n time. So effectively, your total time is n log n plus n, and out of which, what is the bigger term? The bigger term is n log n. So it can be written as order of n of log of n. Got it, Rajesh? Great. So this is what we did in the third approach. Okay, so Gangadhar has given me a question, right? Uh, so it uses bitwise operators. So we have not talked about bitwise operators, but I'll just tell you. So I think this question was uh, not expected, but since it came up, I will tell you what is happening in this case. So did we talk about decimal to binary conversion in any class? Yes, okay, many times we have talked about. Now we need to understand what is this expression, 1 left shift n. So this operator, it is known as left shift, and this is known as right shift. Okay. So given a number, let's say 1. So let's say 1 left shift n. Let us try to understand what it means. So it means it's a bitwise operator. It operates at the binary level. Okay. So let's understand what does mean 1 left shift 1. So what is binary representation of 1? It is 1. So 1 left shift 1 basically means insert 1 0 to the left of 1 in the binary format. So can you tell me what is this number? It is 2, right? It is 2. 2 power 0, 2 power 1. So this number is actually 2. Okay. What about 1 left shift 2? It basically means insert two zeros to the left of 2. Something like this. So can you tell me what is this number? 2 power 0, 2 power 1, 2 square. So it is actually 4. Okay. 1 left shift 3. What is this number? 8. Okay. What is 1 left shift 10? What is this number actually? 1 followed by n zeros. What is this number? 2 raised to the power n. Great. So now what is happening? So it's simply saying that this loop, which is starting from 0, okay, so this loop which is starting from 0, it is running till I less than 2 raised to the power n. And you're saying I plus plus. Got it? So how many times your outer loop is running? 2 raised to the power n times. Okay. Now how many times this loop is running? Let's see. So when I is 0, the inner loop is running 0 times. When I is 1, the inner loop is running from 1 till 0 one time. When I is 2, it is running 2 times. When I is 3, it is running 3 times. When I is 2 raised to the power n, okay, it is running 2 raised to the power n times. So now this is the sum of the series 1 plus 2 plus 3 plus 4 up to 2 raised to the power n. Okay. So now let us assume that this term is what? Let's assume that this term is k. Okay, so it is 1 plus 2 plus 3 up to k. So it is what? K into k plus 1 by 2. This is what it is. Now let us put the value of k again. So k is what? 2 raised to the power n into 2 raised to the power n plus 1 by 2. So it is 2 raised to the power n into 2 raised to the power n plus 2 raised to the power n by 2. So by 2 is not does not matter. So it is 2 raised to the power n plus n. If I take 2 common, I can ignore this. So it is 2 raised to the power 2n. So or this is what the answer should be? Got it? Siddharth says, can you explain the left shift and right shift? Yes, of course, Siddharth. I can repeat it. Okay, let's do it. Let's do a practical demo, right? So we have already counted the outer loop, right? Because when we do this fundamental summation, we are doing this summation. We are counting the outer loop because we are doing this summation here. This is one iteration of inner loop, and doing this sum means includes all iterations of the outer loop, right? So outer plus inner. Okay, let me explain right shift and the left shift. So I only explained you left shift. Right shift is completely opposite. Okay, let me say I have a number 5. I have a number 5, and I say, okay, A left shift 1. So what is the binary representation of 5? Who will tell me? 101. So left shift 1 basically means insert 10 from the left. Oh, sorry. From the right, insert 10. Move everything to the left by inserting 10. Okay, so this actually becomes 1010. So what is this number? 2 power 0, 2 power 1, 2 square, 2 cube. So it is 8 plus 2, that is 10. So this number is 10. So 5 left shift 1 is equal to saying 5 into 2. Okay. What about 5 left shift 2? 5 left shift. So it effectively means this number is now 10100. So 1, 2, 4, 8, 16. So this number is 16 plus 4, 20. So 5 left shift 2 basically means 5 multiplied by 2 square, which is 4. Oh, 5 into 4, that is 20. Okay. So similarly, A left shift B basically means A multiplied by 2 raised to the power n. That means 1 left shift n means 1 multiplied by, sorry, 1 multiplied by 2 raised to the power n. So shift means adding zeros from the other end. Okay. What would be right shift? Exactly opposite. It would be division. So if I say, okay, I have a number 5, and I say, okay, A right shift 1. So that means move everything towards the right, insert a 0 from here. So what this number would be? It would be 10. Okay, so move everything right, this goes off. See, 2 raised to the power 2n can be written as order of 4 raised to the power n. 2 square is 4. Okay. So now, if I say, okay, this number is what? This number is 2. So 5 right shift 1 would mean that divide 5 with 2. So it becomes 2. Okay. Similarly, A right shift B would mean divide A with 2 power B. So 1 right shift n would mean divide 1 with 2 power n. Okay, so got it. So don't worry, we'll cover bitwise operators in the coming classes, and we have 3 sessions on bitwise operators. So we'll cover it. Don't worry. But for the assignment, I think now your doubt should be resolved. Okay. Okay. So we have one more doubt by Nagaraju. Let's see. So for I equal to n, I greater than 0, I equal to I by 2. Okay. Inside this loop, we have for j equal to 0, j less than I, j equal to j plus 2. j plus equal to 2. So that means j is running I by 2 times. Okay, and some work here. So again, this value is a variable. So we will have to do with the basic approach. So we have to say when I is n, how many times the inner loop runs? See, we are going from 0 till I by taking a jump of 2. It runs I by 2 times. Not n by 2, but I by 2 times. Okay. Uh, yes, when I is n, so it is n by 2. That's correct. When I is n by 2, we are running again I by 2 times. So n by 4 times. When I is n by 4, we are running n by 8 times, and so on. So ultimately, when I is 1, we are running 0 times. So we are adding this series n by 2 plus n by 4 plus n by 8 up to 1. So we take n common, 1 by 2 plus 1 by 4 plus 1 by 8. So I told you the sum of this series till infinity is what? A upon 1 minus r. A is 1. So it's n, and 1 upon 1 minus 1 by 2. Is order n the answer? Is the answer order of n? Okay, so did you understand why it's on? Okay, great, great, great. Naga Raju has got it. All right, so with this, I will take your permission. Are there still doubts pending from the time complexity, or is it done? Okay, great. Contest answers. We will do something about it. Okay, we'll do something about constant answers. Okay, so Ankur has given me one question. So let me just solve this one as well. So now Ankur says I equal to 0 while I square is less than equal to n. Then I have a for loop. J goes from 0 till n, j plus plus. Inside that I have another for loop. K goes from 0 till n, k plus plus, some constant work. Okay. So now this loop is running n times. This loop is running n times. Okay. And the outer loop is running how many times? Square root of n times. So that means I is less than equal to root of n. So we have a I plus plus here. So it's I think root n into n into n. So it's uh, n square into n raised to the power 1 by 2. So it's n raised to the power 2 plus 1 by 2. Something like this. Is it? Question is wrong. What is the question? Okay, okay. I saw something. I missed writing I plus plus. Okay, we have I plus plus here. Okay. Now that will make a difference. That will actually change the way it's going to work. So I did not observe this. So let me correct this one, right? Okay, let me tell you one thing. So when you're doing I plus plus here, right? So let's say I was 0, you entered the loop, j goes from 0 to n. So what happened? You said k will go from 0 to n, and I will also go. So that means when I was 0, j was 0, and you entered the loop of k was 0. So k went from 0 to n. I also went from 0 to n. Okay. And that means once you come out of this loop, you will execute this loop again, right? Now j will go from 1, so k will again go from 0 to n. But I plus plus will keep on happening. I will start from n plus 1 and so on. It will go till n plus n, something like this. Okay. But the thing is, you will never enter this while loop again. Why? Because the value of I has already exceeded n. So that means the while loop will run only one time. Hence, the effective time complexity would be 1 into n into n. It will be n square. Got it? Ankur says got it. Shri Vidya says got it. Okay? Great. Yes. So that was the point you had to note. And I hope you really had fun solving these problems. So Chirag says if there are independent loops for m and n, then it should be order of m plus n. But the answer was max of m and n. See Chirag, what actually happens is you can write order of m plus n. Uh, so was this was also an option? Okay. Uh, okay. Send me the link to the question. I will look into it. Okay. So generally, there is a loop that is running m times. There is a loop that is running n times. So effectively, we have to take TS at both are correct. Yes, I think both should be correct. That is what I was trying to say. So order of m plus n can also be written as order of max of m comma n. So that should be okay. Muppa says explain. So Muppa has a doubt. So there is a function. I'm going from I equal to 1. I into I square is less than n. I plus plus. Then I say okay. J goes from 1. J square is less than equal to I, and j equal to j plus I. So Chirag, I will discuss this point in the next class. Okay, let's just hold it. Let me just confirm my apprehensions about it. Okay, we'll do it. So now this is what the question is: I square is less than equal to n. Let me see if I've copied the question correctly from Muppa. Right. So this loop, I know this is going to run root of n times. We are going from 1 till root n. So root n times. What about this loop? So when I is 1, I'm saying j square is less than equal to I. and the update is happening j equal to j plus I. So j will go till uh, and j will also take a jump of I. So how many times this loop is running? Let's say I is 1, I is 2, I is n. Let's say I cannot be n, I will be root n. So it will be root of root n. Inner loop will run only one time. Uh, oh yes, that is correct. This loop will run only one time. See, you are doing j equal to j plus I. So and you are saying I want to run till less than square root of I. So it will run actually only once. So the overall time complexity will be root n because of this update, right? So after you apply this update, you will never enter the second iteration. Second iteration will never happen because if you reached a value that is greater than root of I, okay, so something plus I is always greater than root of I, na? So the second iteration will not happen. So this loop will only run once, and this loop will run root n times. Hence, your answer is order of root of n. Got it? Mupas has got it. I think now I have solved most of your assignment, and if still something is left, you can solve it now, right? All right. So great job, everyone. Thanks a lot for joining. So in the next class, we'll talk about prefix sums. And good night. Take care. Bye bye. My mail ID is pratik.narang@scalar.com.